Okay, so here we've got to figure out what a, n and alpha are given different conditions. So let's have a look at and again we need our x and our v equation. So if we have a look at our x equation and our v equation, so differentiate with respect to t, so the rest is just constants. Okay, so firstly we're given for a the period, and we know the period is 2 pi on n, is 6. So straight away we have n, or you can rearrange it, so you get n equals pi on 3. All right, and then we're given the initial conditions, so when t equals 0, x equals 0, and v equals 5. So let's put that in our x and v equations. So x equals 0, a sine 0 plus alpha, so alpha. And for the v equation, we've got 5 is a n, so we do know n, we can put that in as pi on 3, or I'm just going to leave it for the moment, cos of 0 plus alpha, so cos alpha. If I put those two together, so if I do a sine alpha over a n cos alpha, because I've got 0, so I'm still going to get a 0. I'll do it properly. All right, so I'm going to get, let's just rearrange that for a second. So if I do, and this would be 0 on a is sine alpha. So you can do this all different ways, and you'll see, I think in the textbook it does it a different way. So, but if I just do this equation 1 divided by this equation 2, I'm going to get 0 on a divided by 5 on an. Doesn't really matter what I do, I'm still going to get a 0 on top. For C, 0 divided by a is 0, so this is 0 divided by something which is still 0. So I'm going to get, in effect, tan alpha equals 0. Now, when does that happen? Between 0 and 2 pi, the first time that happens, we have alpha equals 0. And you can see it's allowed to be 0. It's between 0 including 0. So we've got alpha equals 0. Let's put that in the cos equation to find a. So let's go back to the cos equation here. And we've got 5 equals a, what was n? N is pi on 3. And we're saying cos 0. Cos 0 we know is 1. So to rearrange and make a the subject, I'm going to times by 3 divided by pi. So a is 15 on pi. All right, so let's try the second one. So for the second one, I just do this again. The second one, the period is 3 pi. So let's make that equal 3 pi and solve that. So we'll get 2 pi, n is 2 pi on 3 pi, which is just 2 on 3. So that's n. We've got the initial conditions, t equals 0, x equals minus 5, v equals 0. So let's put that in. So minus 5 equals, a sine alpha, and 0 for velocity is a n. We've got n, but I'm not worried for the moment. So I could use it, or a fun way maybe to put these together and do sine squared plus cos squared equals 1. So sine squared, if I use the fact that sine squared alpha plus cos squared alpha equals 1, what does sine squared equal? If I rearrange the first one, I get minus 5 on a, it's my sine squared. Cos squared, I'll get 0 on an all squared, so that's just 0 anyway. I'll do that. So here I've got 25 on a squared equaling 1, so a squared would be 25. So now a would have to be 5 since a has to be greater, has to be greater than 0. Sorry about that. So we've got a equals 5. All right, so let's use that in this equation and get alpha. So we're going to have minus 5 equals a is 5 sine alpha. So divide by 5, we've got negative 1. So -1 is sine alpha. We know that is in the second quadrant. So -1 we know would be 3 pi and 1.5 pi. So actually in the third quadrant, so 3 pi on 2. All right, so let's do C. So for C, I'll do it over here. We know we're given that, 2 pi on n, so the period is 2 pi, so clearly n equals 1, so that's nice and easy. Initially, x is 1 when t is 0, and v is -1 when t is 0, and I've put n equals 1 in there as well. All right. So again, I could do sine alpha on cos alpha, which is tan alpha. And you can see I'll get the a's will cancel as well. So it's like a sine alpha divided by a cos alpha is just tan alpha. And 1 divided by -1 is -1. So alpha must be 3 pi on 4, 3/4 pi, because we're in the second quadrant. So that's our alpha. Putting that back into our first equation. Yes, my working is terrible, but hopefully this is just helping you to understand where we're getting things from. So here I've got 1 equals a sine 3/4 pi, which we know is in the second quadrant, so sine is negative, so sine is positive, pardon me, same as pi on 4, so 1 on √2. So rearranging that, I will get a equals √2. Hope that helps.